So our basic learning goal today is being able to multiply polynomials. I can multiply polynomials, and then after you multiply them, you don't get to just say you're done because you've done the multiplication. You also have to make sure that you combine any like term. In other words, you simplify it. You make sure that it cannot be renamed anymore. Okay? So when we're multiplying monomials, remind what's a monomial? What's the definition for a monomial? Ooh, this should be memory by now. What's a monomial? Chase? If all else fails, you say something like a word that starts with M. Pardon?
Multiply?
No, there can be some multiplication going in a monomial, though. I will give you that. No, I was not asking you for another word that starts with M. I was giving you a suggested way to answer it. What's a monomial, Benton?
Polynomial with one term.
A polynomial with just one term. And that one term can be made up of what?
Any number.
A number? Or a variable? Or a product of numbers and variables. Is there any addition or subtraction going on in a monomial? No, not. So, when we are multiplying our monomials, we can do the following three things. Drop the parentheses that are actually just showing multiplication, one monomial being multiplied by another monomial. We can drop them and insert multiplication symbols instead. Rearrange the factors so that the things that really can be multiplied together are kind of grouped together, and then multiply from there. Okay, so number one, we have monomial 3x squared times monomial 6x. We're going to drop the parentheses and show that we really have here the multiplication of 4 factors. 3x squared means 3 times x squared. 6x means 6 times x. And parenthesis backed up to parenthesis also means multiplication. So we really have 4 factors here, and that's important that you know how to identify that also. All those pieces of this multiplication problem are called factors. Now what we will do is rearrange our factors so that our answer is given in either standard form or algebraic etiquette form, maybe to say. So the 3 and the 6 can be multiplied times each other. The x squared and the x can be multiplied times each other. We're not adding, we're not subtracting now, we're not really looking for like terms to add or subtract, but we're looking for factors that can actually be multiplied by each other. So 3 times 6 is 18. And x squared times x, can we do that?
Yes.
Okay, what do we do? Benton?
Just make it x cubed or x to the 3rd power.
Okay. And what allows us to do that?
Because if you break down x squared, it's just x times x. And if it's x times x times x, it's x cubed.
So we really have 3 factors of x here, don't we? Remember the shortcut for that is? You have a same base. You can add their exponents when you're multiplying. So we really have 2 plus 1, which becomes x to the 3rd power, as Benton said, and then cleaned up, we would write this 18x to the 3rd power. Okay, you do the next one on your own. After you drop the parentheses, inserting the multiplication symbols, the dots, because x we don't use anymore. We unfortunately might think that is the variable x, so we use the multiplication dot. How did you rearrange this? How do the factors get rearranged in this to make it so that when you're done actually multiplying, it will be so nicely in algebraic etiquette form? Give me the rearrangement of this. What is that? What would my next step look like? 2 times 5 times a times b to the 5th, or 3rd, excuse me, that's not a 5, that's a 3. That's a 5 above it, times b to the 2nd power. Now we can actually do the multiplying. 2 times 5, 10. 8 times, doesn't have anything to be multiplied by, does it? There's not another factor with a base of a and b to the 5th, because we add those exponents. Okay. Go ahead, get what the answer is for the next one. What's number 3's answer? And I want to see a rearranged step. I want to see what are all those factors. There are several of them. What do they look like after you rearrange them? Cameron, give me the first 3 factors in the rearrangement. Three, I need one more. I think we might want to look and see if there are any more constants. Negative 1, yeah. Let's take care of that negative 1. Okay. Have we used all the constants now? Have they all been moved to the front? We had this constant, and this constant, and it looks like that's all of them. Okay, what would be the next 3? Because there's 9, so I'm going to do them in groups of 3. What would be the next 3 in this? Austin?
Times x squared times x to the 3rd.
One more. We're doing them in groups of 3, just for, you know, for the fun of it out loud. So what could be the next one? So we've used this one now, we've used this one. Negative y to the 4th? No, I already used my negative 1. It's back here. Okay, y to the 4th, I can use that. Okay, what would the last 3 be then? Eddie? So we want to start with the constants. The constants can be in any order you want. But that negative sign, that's really a negative 1. It's a constant. It needs to be out there with those other constants. And then x comes before y, comes before z in the alphabet, so the x factors are next. Any factors that have y as their base are following, and any factors that have z as their base are following. So now a third of 12 times negative 1, what do we get? Negative 4. What do we get for the x's, Colin? X to the 5th. What do we get for the y's, Easton? Y to the 4th? Okay. 5th. Okay, which one do you want? 5th, okay. And what do we get for the z's, Macy? Z to the 7th. Everybody agree? Okay, cleaned up it will just be negative 4, x to the 5th, y to the 5th, z to the 7th. We do not need the multiplication dots. We make sure we have the variable factors in alphabetical order and the constants out front. Okay, that's multiplying monomials. Again, in monomials we see no addition, no subtraction. We should end up with a monomial product. And we're done. Anybody have any questions on those? Okay, what if we have something other than a monomial as one of our factors, and one of the factors is a monomial? So multiplying a polynomial by a monomial. Now we have to do distributive property, because distributive property is how we multiply over addition and or subtraction. So now we will do our distributive property, and we will actually be and then we will multiply the monomials that we have left. So we have to take this monomial times each of the monomial terms of the other polynomial called a what? What's a two-term polynomial called? Binomial. So we're going to take 3ab times 5a, and yes, I want to see this written like this in your notes. 3ab times 5a, the first multiplication of the distributive property. Bring down the addition sign that is between our binomial terms, and then that 3ab has to be multiplied times the b also. So you should have two multiplications going on, that then in the end, we will see if we can add them together or not after we do the multiplications. Okay, go ahead and multiply those, because that's a monomial times a monomial. And then there's another monomial times a monomial. You should get two terms that are monomials when you're done. At this point, I have a binomial, but I'm wondering if I can make it into a monomial. Do you agree with me that the first product should have turned out 15a squared b? Agree with that? Okay. How about the second product? Agree with my second product? 3ab squared. Okay. Can I simplify that anymore? Can I make that into just a monomial? We should be adding polynomials now. Now we're adding polynomials. Can we add these together? Okay. What will it become then? 18a to the third, b to the third? Do we agree? Maybe not Benton. Benton, why do you want to not agree?
Because if you add b squared plus just b, it's not, you wouldn't have it as b to the third.
We're not multiplying, are we? We're adding. What has to be true when we're adding? What has to be true about those variable parts? They have to be the same. Are they the same? Is a squared b, that's the variable part of this one, the same as ab squared? No. So don't be fooled into thinking you can make this any better. It's addition at this point now. It is not multiplication anymore. So the final answer is just that binomial. 15a squared b plus 3ab squared. Can't put them together. Just go to the back and practice one on your own again. Try that one, see how that goes. Of course, you know me, I said, when we were subtracting, especially last week, I said change those subtractions to add the opposite. But if you're going to be stubborn and not do it, and you don't get the right answer, I'm going to say give in. Okay, so go ahead and multiply this out. You should have 3 multiplications to do, because there's a monomial times a trinomial. You should have 3 multiplications going on of a monomial times another monomial. Before I even multiply, I'm thinking that might be good. I have found that oftentimes when you're multiplying monomials over polynomials that are especially 3 terms or more, it's just a good idea to, put some rectangles around your multiplication so you can see, do I have all the multiplications I need to have? And then you can work with them from there. You keep working because you're going to check me out and see if I'm right. I'll clean it up and then you can compare with my answer and see if we agree. Here's my final answer. Anybody agree with me? Next date? Okay, well, not feeling that. Tate and I, right? Peyton, you agree, Caleb? Okay, getting better. Eddie? Austin? Finally? Okay. Colin, you did too, right? Okay. So, are any of those like terms? In other words, could we do any real addition here? So we did all, it was all multiplying before, and now after I did the multiplication, how come I didn't put any of these together? How come I didn't say all together there's negative 6 plus 2 minus 8, y to the 6th? Why didn't I do that? Should I have? Why not? How do you get y to the 6th when you're what? From y cubed and y squared and y, how do you get y to the 6th when you're doing what? Multiplying. Are we multiplying anymore at this point? No, now we're looking to see if anything can be added together. They have to have the same variable parts, right? And they have to be considered like terms, and we don't have any like terms right now. Okay, anybody want to disagree or ask any questions? Open your books to page 423, please. We're going to do what has been named, when you multiply a binomial times another binomial, they've called it the acronym FOIL. And it's just a fancy way of saying, here's how you do distributive property when you're doing a binomial times a binomial. In other words, there's not just a monomial times another polynomial. There's no monomial factor in this one. We have a binomial times a binomial. When we have we have to use, we still have to use distributive property. Every piece has to be multiplied. So that's where the FOIL comes in. Okay, so would you look that over quickly and so that you're going to be able to tell me what each of those letters in the acronym FOIL stand for? It's in that nice tan box on the bottom of page 423. Got it?
First, outer, inner, last.
Okay, so F is for first. First meaning first what? First terms of each binomial get multiplied. What does I stand for? You did inner. What's that mean, inner?
The closest.
The ones, excuse me, O would be next, not inner. O is next, which stands for outside. What do they mean by the outside?
Outside terms.
So the first one of the first binomial and the last one of the second one, so they're on the outside, they're on the outskirts, okay? And I stands for inner, those are the ones that are
On the inside.
on the inside, they're the middle ones. They're the end of the first one and the beginning of the second one, right? And then L stands for last, and that is the last of each of them. So here's what really happens in FOIL. I just want to show you what's the one that they do in that one? What's it called? What's the binomials. Can you tell me what they are? X plus 3, x plus 2, okay. So they're really doing distributive property, just like we were just doing in those last ones, except now we don't have a monomial times another polynomial. This x has to be multiplied times both of those guys. And this 3 has to be multiplied times both of those guys. So there's 4 multiplications that have to go on, and that's what happens in FOIL. So the f would be this first arm that I drew here. The O actually turns out, excuse me, the F would be this arm right here, not that first arm. This would be the F, this would be the O, this would be the I step, and this would be the L step. So when we're setting these up, we're just going to write those letters down and then just show those 4 multiplications so that we get a feel for how this works when you can start doing it in your head. Okay, the first thing that I suggest you do, though, is, my usual change addition or subtraction to add the opposite. Because in multiplying, this is when subtraction and negatives and all these things kind of start causing issues. So if you rename it, now when you set up your F, O, I, L steps, hopefully you will be successful. So what would be our multiplication in the F step? Avery? A times A. Which is A squared. What would be our multiplication for the O step? Lindsay? A times negative 4, the outside terms. And what is that? Negative 4A. What would the I steps multiplication be, Elizabeth?
3 times A.
3 times A. And that product is 3A. And the L step for this one would be, Haley? 3 times negative 4. And Hayden, that would be? Negative 12. Well, those 4 products now have to be what? Not multiplied. This is now an addition problem. This becomes an addition problem. So here's what I like to do. I always like to check when it's lined up like this and see if any of these are like terms. Are any of those like terms? Yeah. Which steps did turned out to be like terms? The O and the I. So what does that combine to become? What's negative 4 plus 3A? Negative 4A plus 3A. What's that become? Negative A. Negative 1A, also known as negative A. Are there any other like terms in that list of products? No. So now we can say, you know what? Then the answer is A squared, subtract A, subtract 12. Okay, how would we do this next one? X minus 3 in parentheses squared. Did we FOIL this one? Yeah. How would you FOIL this one? And you would what? Put them right next to each other. In other words, give it its name before it got renamed. So what would this look like? How could I rename this? What would it look like? No multiplying, no, I don't want you doing multiplying. What's x minus 3 squared mean? Benson?
X minus 3 times x minus 3.
Yeah. Really means 2 factors of x minus 3, right? No. The reason that I want you to rewrite it like this is I don't want your brain to be tempted to do this. Say, well, I just have to take the x times the x. I'm going to take the 3 times the 3, and presto, I'm going to put it in maybe an addition sign between them, or maybe that day I feel like a subtraction sign, I'll put a subtraction sign between them, and my answer will squared minus 9. In other words, you might think you could shortcut it, because we remember when we were doing exponents, we would give the exponent to each of the factors of a product, but this has got subtraction going on in it, so we can't use that little rule. So instead, what we're going to do is we're going to say we really have x plus negative 3 times itself. F-O-I-L. What's the F step look like, Easton? X times x, which is x squared. Chase, what does the O step look like? X times 3? Negative 3, yeah. We gotta, that's subtraction. If you don't want to change it to add the opposite, that's subtraction. Say, Cameron, has to come along with it. Are you with us? Yeah? Okay, what is x times negative 3, class? Negative 3x. What's the I step going to look like? Riley? Oh, that voice is in again. Okay, I'm going to do it like this, though. I'm going to take, it's I. I'm going to let the first one that's in the inside be first. Negative 3 times x. Does it matter in multiplication? No. We're going to get the same product anyway. And then the L step is what, class? Negative 3 times. And that is positive 9. Okay. There's really addition going on between all of these. So at this point, I could take this and say, are there any like terms?
Yes.
Which ones?
Negative 3x.
The negative 3x and the negative 3x. They combine to become what, Colin? Negative 6x. So the final answer for this one is, what do you get for it, Hayden?
X squared minus 6x plus 9.
Yeah, we didn't get x squared plus 9 or x squared minus 9. We got x squared minus 6x plus 9. Okay, so no shortcuts allowed in this when they are the same factor. You still need to multiply them out. So any questions on FOIL? Binomial times a binomial. Please. Got a question on FOIL?
No.
Then don't put your arm up. Anybody have any questions on FOIL?